All right, so in this video, we're going to continue looking at the differences between periodic and aperiodic signals. So let's go. Let's talk a little bit about the time domain and the frequency domain. In the time domain, periodic signals repeat themselves like that, and aperiodic do not. In the frequency domain, periodic signals are going to have spectral lines, like lines in the spectra. And aperiodic signals are either, they're going to have like a flat line, it'll be just continuous, or they'll have some lines, but they're just kind of jumbly, you know, just garbage everywhere. No like perfect, you know, fingers of harmonics and fundamental frequencies. Okay. What do you think about this signal? Wow, that took a long time to get that. It's even on the slide. How could I forget the word signal? What do you think about this signal? Is it periodic or aperiodic? It's periodic, of course. Now, let's do something else really quickly, just because I see this as a time that we can... there we go. Okay, so I see this as a time that we can do some other extra work. What I want to know is what is the fundamental period and what is the fundamental frequency. If you want to figure it out for yourself, pause the video now. And welcome back. And so we're going to figure this out. So I see right here, the signal starts on a major grid line here at 0.86, and it's going to repeat again on a major grid line here at 0.92. So let's go ahead and 0.92 minus 0.86 is 0.06. Yeah, I probably could have done that in my head. Oh well, it's easier with a calculator. So I get 0.06. Hair's still going crazy. These headphones, man. You just can't get your hair to be cool. Okay, so 0.06 is my fundamental period. Now, to get my fundamental frequency, I'm going to follow the formula we had before of frequency equals 1 over period. And so 1 divided by 0.06 is 16.67 hertz. This is not a sound that we can hear. We can't hear below 20 hertz. That's okay. Yep, 16 hertz. Okay. So that's a pretty low frequency. Let's continue. So this was periodic. Is this periodic or aperiodic? If you said periodic, you're wrong. But if you said aperiodic, you're right. What about this one? Periodic or aperiodic? This is a tricky one. It's a tricky one because if you're just looking at your peaks, you might think that this repeats. At 0.01, at 0.02, at 0.03, we've got a large peak. But look at the nadir. Those don't repeat. And look at the general shape. That doesn't repeat either. This is aperiodic. Now, if you want to know, like really technically, it's probably aperiodic with a little bit of a signal inside of it. Something that does repeat every 0.01 seconds. But mostly, it looks like garbage to me. And that could be an accident. I mean, sometimes aperiodic signals just accidentally occasionally look like there might be something periodic inside of them. But this is definitely mostly aperiodic. Don't be fooled by things that look like they're repeating. It's an aperiodic signal. Okay, so now we're looking in the frequency domain. Is this periodic or aperiodic? Remember, you're looking for, well, go ahead and come up with an answer. What you're looking for in a periodic signal are spectral lines. And if it's an aperiodic signal, you'll see something more like a flat spectrum or something that kind of slices down like that pink noise that I showed you, or just garbage, complete garbage. What do you think this is more like? Well, I see spectral lines here. So I see that there is a really large area of energy here, 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 and here, and here. It starts to get a little bit less and a little bit more noisy up in the high frequencies, but that's okay. There's a lot of good representation of spectral lines here. So this is a periodic signal. Okay, so now we're back at, nope, we're still in the frequency domain. What do you think about this signal? Periodic or aperiodic? If you said aperiodic, you're right. This is an aperiodic signal. When you can't really tell if you're in frequency time domain or frequency domain, it's probably aperiodic. But this is just as all over the place as that white noise signal that I showed you. There are lines in the spectrum, but they're not well defined and evenly spaced lines in the spectrum. These are random and gross. These are evenly spaced. We could figure out what it is. It looks like there's 1, 2, 3, 4, 5, 6, 7 of them in 800 hertz. So it's like 114. Is what that is. 114 hertz. And 1, 2, 3, 4, 5, 6, 7, 8 harmonics, maybe 9, 10, 11, maybe 11. This one, there's nothing like that. There's no evenly spaced. There are lines, but they're not evenly spaced lines. This is nothing. Okay, what is our fundamental period for this signal? Go ahead and pause the video right now if you want to compute it for yourself. And if you, welcome back. And it looks like our fundamental period here is, we can see that it repeats again. It starts at 0.86 and it repeats again at 0.94. But how many of them were there? Hey, wait a second. I just realized something stupid that I did on this one. Sorry about that. From 0.86 to 0.92, I just subtracted this, and it was 0.06. I did not divide that by how many times it repeated. Maybe you caught that. You probably did. And you're like, Dr. Patton, what are you doing? So this repeats 1, 2, 3, 4, 5, 6, 7 times. So this was 0.06 divided by 7 is 0.00857. So we're going to do 1 divided by 0.00857. This is 117 hertz. And that we actually can hear. Lowish, but we can hear it. Okay, next. Let's go back to the one that we were on. Right here. So again, it starts, we can find an area where it starts at 0.86. We can find an area where it repeats again at 0.94. So 0.86, well, 0.94 divided by 0.86 is 0.08. And then we need to count how many times it repeats, which is 1, 2, 3, well, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to take our 0.08, divide that by 9. 0.0088888888888, and that's our fundamental period. It's 0.00888 repeating. What's the fundamental frequency? Well, you put 1 over 0.00888888889, and you get about 112.5, roughly. So that's your fundamental period and your fundamental frequency. All right. This is what actual speech sounds look like. Is this periodic or aperiodic? Well, it's periodic. You can see that there are like these spectral lines here. You've got this one, 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 all these going on. Now, again, you know, like I said, there's some noise, this low-level noise right here. That's okay. And then as you get into the higher frequencies, there's a little bit more noise. Real signals aren't ever going to look completely perfect, but this is periodic, and you can still see the spectral lines. They're more evident at lower frequencies, but they're still there at higher frequencies. So what is the fundamental frequency? If you want to figure it out for yourself, pause now. Welcome back. Here's how we're going to do it. Our fundamental frequency, we're going to find where it crosses right here. Here's a major grid line where we have a repetition. It's at 800 hertz. We've got 1, 2, 3, 4, 5, 6, 7. This is just like the other one that we did. So it should be 114. I'm going to take 800 hertz divided by 7. Yeah, 114. Oh, I have labels. Yeah, there. So 800 divided by 7 is roughly 114. What is the fundamental period? You have to work backwards. So, how do we do that? Well, the formula is F equals 1 over T. Well, there's something that we can do, which is if we multiply both sides by T, that gets rid of the T on the bottom of the formula. It gets rid of the T in the denominator. And then what you end up with is F times T equals 1. What we want is T. We want to get T by itself. So we can divide by F on both sides. And then what you get is T equals 1 divided by F. Isn't that totally crazy? So the formula for fundamental frequency is 1 over T. The formula for fundamental period is 1 over F. So all you got to do is 114 1 divided by 114. equals 0.00877. Yeah, right there. I will show you that change in that formula visually in one of the math reviews, the math review in this module. If you didn't catch how I was getting there, I'll actually like show it to you how to get from one to the other. But basically, if you're committing it to memory, f equals 1 over t, t equals 1 over f. So it's pretty simple how those turn out. Okay, well that is the end of this video. And the next video is going to be different. There you're going to learn how to use Pratt and Audacity. So I will see you next week. You'll see me in the next video. It's a different thing that you're doing. So then you're going to be coming back for more actual, like content, learning this kind of stuff next week. Okay, see you soon.